Hi everyone, welcome to chapter 7. This is section 7.1 and we're going to be talking about multiplication properties of exponents. So as you see by our objective, we're going to multiply monomials. We're going to simplify expressions using those properties. So first we should probably talk about exponents and we should probably talk about monomials. So exponents, you've all seen them, but I want to make sure you know the terminology. It's base to a power. So for example, if we have 5 to the second power, or we say 5 squared, right? That's what we are going to do. We're going to multiply the base by itself the power number of times. That's kind of awkward. I didn't know how else to say it. But that means we're going to take 2 5s and we're going to multiply them. So if we've got x to the 5th power, or x to the power of 5, that means how many x's do we have that we're going to multiply them. So the base is always the thing that gets multiplied. And I think a good way to do this, or say it, is to talk about repeat multiplication. Sometimes people think 5 to the second power is 10. You did repeat adding. This is repeat multiplying. So repeat multiplication. So x to the 5th power is x times x times x times x times x. We're going to use that expansion where we write it all out starting in this section when we use those properties of exponents. So repeat multiplication. So monomials, I mentioned monomials as well. A monomial is any number, variable, or the product of numbers and variables. What's product always mean? Multiply, right? So we could have, for example, a 3. That's a number. We could have a variable like y. Pick one that you like. Or we could have a product of those things. So I might have a 5x to the 3rd power. Right? That's all multiplying, because remember, x to the 3rd power is repeat multiplication. It's x times x times x. We're taking the product of a number, 5, and 3 x's. We're all multiplying those all together. So those are all examples of monomials. Notice there is no addition, there is no subtraction, there is no division in the form of a fraction or a division, old school division sign. A constant is a special kind of monomial. It's a real number. Typically, we're going to use exponents. So -2 would be an example of a constant. Or 8. So constants are real numbers. Again, we could have rationals and irrationals. I'm usually seeing integers, sorry. So let's take a quick look at this. Is it a monomial or is it not a monomial? So the first questions that I'm going to ask you about are yes or no questions. It does have explain. Determine whether each expression is a monomial and explain. So for letter A, x plus y, is that a number, a variable, or the product of numbers or variables? What's your big clue in there? Addition sign, right? We don't have addition signs in monomials. Addition. Right below it, letter B, I've got a -5. That's definitely a monomial. It's a special kind of monomial called a constant, just a plain number all on its own. Letter C is kind of a tricky one. ABC all over 5. So remember when we were doing our linear equations and we were putting them into y equals mx plus b form, we would usually take those variables and put them on the side and do like 1/5 ABC. If you've got 1/5 ABC, do you see the product of a number and variables? We're doing 1/5 times A times B times C. So this is a monomial. So then you're not going to be fooled by D, right? 8f squared g. That's all multiplying. It's really 8 times f times g. All products. How about E then? X squared over y. Remember, no division, only multiplication. So really that's x times x divided by y. So that's a big And of course, then f, you won't be fooled by that. We've got ourselves a variable in the denominator, which means we are doing division. And monomials are just multiplication. Okay, everybody else set with monomials? So yes or no questions, of course I'm going to ask you to explain because that's what I do. So now let's talk about these properties of exponents, but I call them shortcuts because a shortcut is only a shortcut if you understand and know how it works. So I want to make sure I talk about this. So we're going to simplify. I'm going to tell you the shortcut. I'm going to do the example before we do the shortcut because I want you to see it. And I'm going to ask you to write these out in expanded form for the first few assignments because I want you to understand why that shortcut works. But at the end, I'm going to ask you, what do you think is easier? Do you understand the shortcut? So if we're going to talk about product of powers for our first one, product of powers is when we have something like x to the third times x to the fifth. First of all, each one of those are monomial, right? X to the third means if we write that out, repeat multiplication, that means x times x times x. If we're looking at x to the fifth, how many x's do I have? 5 of them, right? 1, 2, 3, 4, 5. So if I'm timesing all those things together, how many x's do I really have here? Do we really want to write out x to the third times x to the fifth when we could write out, if this is repeat multiplication, how many x's did I write out in purple and orange so that I know that will be my new exponent, right? I'm multiplying 1, 2, 3, 4, 5, 6, 7, 8. So if we write it all out, we can count them. If we're thinking shortcut, what do you see that we did in order to get from the original problem, x to the third times x to the fifth, to our answer, x to the eighth? You're going to keep the same base, but add the exponents. So remember, it's base to a power, so it's still x, and then add the exponents. 3 plus 5 gave us 8. So the next one is power of a power. In other words, we might have something like, I'm going to stick with x to the third, but now I'm going to do to the second power. So x cubed to the second power. So let's write that out. So in other words, this squared right here means that we've got x cubed 2 times. If we're being technical, that means that we've got 3 x's here. I'm going to scooch these in. 3 x's here, and everything's being multiplied together. So what is x cubed to the second power? If we're doing repeat multiplication, how many x's do I have down there in green that's going to be my final answer? X to the sixth power. So I can write it all out, or I can use a shortcut. Again, the shortcut never works. You never get home with a shortcut if you don't really know the way. So my shortcut, if I'm not going to write them out, is to keep the base, again, this time it was x, and multiply my two exponents. If you go back to that original problem, x cubed to the second power, the 3 times 2 gives me that 6, because I had x cubed twice. And our third and final property for today is power of a product. So I might have something like 2y to the third power. So I've got a product, 2 times y, and then I'm raising that whole thing to the third power. By the way, if I didn't have x or parentheses around the 2y and I just had the cubed, that 3 would only be on the y, not on the 2, so I have to have parentheses there to show that. So if I'm going to think about this in a logical way, this 3 tells me that I've got 2y 3 times for repeat multiplication. So if I've got 2y times 2y times 2y, well, first of all, think about 2 times 2 times 2. Please go to your calculator for that because it is not 6. 2 times 2 is 4 times another 2 is 8. And then how many y's do I have that I'm multiplying together? Even though they're broken up with the 2's in between, I still have 1, 2, 3 y's that I'm multiplying. So since I'm multiplying 3 y's, my exponent is a 3. So really, exponents are a shortcut for writing things out. So here's the shortcut for this one. This one seems to be the one that people like to write out because it's hardest to kind of wrap your brain around. So what you're going to do, almost like distributive property, you're going to distribute the exponent to each base and then do the math. So I'm going to do 2 to the third power, and I'm going to do y to the third power. Again, this is the one that messes people up because that 2 to the third is 8. And then sometimes you get confused, and what am I doing with that? So write that out if you need to. 2y times 2y times 2y. Any way it goes, you get 8y to the third. So again, I'm going to ask you to write these out at the beginning, to write them out the expanded way so that you can see them. As we get into this chapter, I'm going to say if you understand these shortcuts, please use them. It will just make it easier for you. Let's talk about one last thing before we do a couple example problems. So first of all, I'm going to talk about simplifying monomials. Here's the rules for simplifying. It is not simplified unless each base appears one time only. You can't have an x squared in the numerator and an x to the third in the denominator, because that's just not cool. So you got to make sure all your x's get canceled out and simplified and things like that. Or you can't have an x cubed times an x to the second, because the base x shows up 2 times. So we want to write that as x to the, everybody know what power that's going to be? Right, if I've got 3 from the first, 2 from the second, I've got 5 x's altogether. An expression is not simplified unless there are no powers of powers. So that property that we just did, the power of a power, or the power of a product, the bottom 2 boxes, if you have that still, you're not done with the problem. You have to make sure you take care of all powers of powers. If there's powers of powers, that means you got parentheses in there. And we all know to get rid of parentheses anyway. A monomial is not simplified unless all fractions are in simplest form. Nobody would keep 2/10 for a fraction, because you know I'm going to say to you, please write that as 1/5. Your problem is not done. So if you have a fraction, make sure it's simple. And last but not least, a monomial is not simplified unless your exponents are positive. We'll talk about that in 7.2. Don't worry about that quite yet, but I figured I should just use the complete list and then we don't have to rewrite it. Here's all the rules to make sure you've got a simplified expression. All right, so now let's do a couple problems. Let's do number 2. We'll skip 1. So as we do these notes, we may skip example problems. Those are good ones for you to go back and use as extra practice, before a quiz, before a test. I have all the answers. I can tell you what the answer is, and you can verify. So we won't do every example. If you have noticed, I like examples. And you guys have a tendency to not want to do all the examples. But this gives you a chance where you've got problems on the paper that you can go back and double check and review those. So for number 2, I'm going to write this out in expanded form. So my first set of parentheses, don't try to do too many things at once. My first set of parentheses, I've got a 4ab to the 5th. So that's 4 times a, and yes, I'm going to write out 5b's. You can put parentheses around them. You can just put a times dot in between the 2 separate expressions, whatever makes you happier. But I want to see that you've got 5b's. My second part, I've got a -7, a squared b to the third. So I've got 2 a's and I'm running out of space. So I'm going to put my b to the third down on the bottom line. So b to the third is b times b times b. So if we're going to write our answer to this, we need to do the math. So do the number math. What is 4 times -7? Hopefully everybody knows that's -28. We've got a's all over the place. So count them. How many a's do we have? Remember, this is repeat multiplication. I've got 1, 2, 3 a's. So that means I've got a to the third power. And my only other variable is b. How many b's do I have? 1, 2, 3, 4, 5, 6, 7, 8. So that gives me a b to the 8th. So my answer to this problem for number 2 is negative 28, a to the 3rd, b to the 8th. Everybody okay with that one? So try number 4. So I'm going to write out my 6cd to the 4th. 6c, d, 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 d. Yes, I want you to write it out at the beginning. Some of you are going to be like, oh my gosh, I don't need to. That's the point, is that you understand what you're doing. My second half of my problem is 5c cubed d squared. So 5c, c, c, d, d. Notice I don't even put dots in between them because I know that they're multiplying. You certainly can. Feel free if that makes you happy. But let's do our number math first. 6 times 5, I'm hoping everybody tells me that's 30. How many c's do I have all over the place in this problem that I'm multiplying by? So I've got 4 c's, so I'm going to have c to that power. So count up your c's, that's your exponent. How many d's do I have? I've got 4 in this first half of the problem. I've got 2 over here, so that means I've got d to the 6th. So my answer for this is going to be 30, c to the 4th, d to the 6th. Everybody feeling pretty good about this? All right, so let's go down here. We really need to talk about all these problems, I think, because number 5 is a pretty big and ugly problem, right? So start at the farthest out exponent. So this 2 right here tells me that I've got a to the 4th cubed twice. And then my a to the 4th cubed, this exponent tells me I've got a to the 4th 3 times. And the same on this side over here. A to the 4th times a to the 4th. This is going to be a lot of a's. Do you already know how many a's we're going to have for this? So 4 a's for each of these. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. This is a really fun problem, isn't it? 2, 3, 4. 1, 2. Holy man. So how many a's do I have? What's my answer going to be for this ridiculously large problem? I've got 4 a's down here written in orange. 4, 8, 12, 16, 20, 24. If I want to go back and double check or make sure that I've got my shortcut right, don't leave, class is not over. Hopefully the announcements and the pledge won't come on. I'm going to do 2 times 3, and you can do this in any order because we know commutative property order. 2 times 3 times 4 should get me my exponent a to the 24th power. 2 times 3 is 6 times 4 is 24. We did the problem right. I know that was a big messy problem, but it's kind of a cool one when you look at breaking it all down. Number 6 we should talk about. Find the length of the volume of a cube with the length of s equals 5, x, y, z. So first of all, you need to know that the volume of any cube is side length to the 3rd power. We're going to do some substitution right here because it tells us that the side length is 5xyz. We're going to put the big parentheses around that 5xyz and raise it to the 3rd power. So that is the property that we talked about. That was the last one, the power of a product. So we know that volume is going to be equal to parentheses 5xyz all to the 3rd power. So if we're doing this the way I want you to do this, this means I've got 5xyz 3 times. Nothing more to expand after 5xyz. And I don't like z's because they sometimes look like 2's. Be careful. So we're going to do the number math first. 5 times 5 times 5. Double check me. I think it's 125. X times x times x. So what is my exponent going to be on my x? How about my y? How about my z? Everybody good with a 125, x to the third, y to the third, z to the third. So when we talked about the shortcut, this is where I said, oh, well, this is where we could distribute. Put the 5 to the third power. That's the part that people struggle with the most. It's not 15. X to the third power, y to the third power, z to the third power. So if we double check with the shortcut, we did it correctly. Number 7, I've got, notice where the parentheses and the exponents are. This is why I want to do these two last problems, 7 and 8. So for number 7, take each half separately. So if I've got an AB to the second power, that second power tells me I've got AB 2 times. Repeat multiplication. That's the first half of the problem. The second half, this AB squared, is just A, and I'm going to expand out that B squared to a B times B. So now, when I'm writing out my answer, I've got 1, 2, 3, so A to the third power. What's my B exponent going to be? 1, 2, B to the 4. So my answer is A cubed, B to the 4th. We could double check that using our properties. If I'm going to distribute this to both things, I've got A squared, B squared. And then our shortcut, remember, is to add the exponents. So if I've got an A squared right here, and I've got this A right here, here's the trick. Be careful. If I only have an A sitting there with no exponent, it's kind of like the default setting. There is an A there. There's one A. So no exponent means it's a 1. So when we add up our exponents, A has a 2 plus 1, which is a 3. B has a squared plus a squared. 2 plus 2 is 4. Last example, 2gh cubed all to the 4th power. So again, I know it's a little messy over here, but that 4th power tells me I've got 2gh cubed 4 times. I'm going to cheat. 1, 2, 3, and, uh-oh, running out of space. 2, 3, and last one, 4. Scooch them all in there. So if I'm expanding this, I've got 2GHHH. This one I've got 2GHHH. This one I've got 2GHHH. Again, I get a little lazy. I don't put the timesing in there. Feel free to do that. Here's all my stuff. I'm going to highlight them. Here's all my stuff that I need to combine. So let's do the number math first. 2 times 2 times 2 times 2. Be careful, go to your calculator. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. What about g's? What should my exponent be on my g's? How many do I have? How about my h's? Well, I've got 3 h's from each set, so I'm looking at 12 h's altogether. If we're going back to the shortcut, again, a shortcut's only a shortcut if you understand it. I do 2 to the 4th power. I would do g to the 4th power, because 1 times 4 is 4. And I do h to the 3 times 4, or 12th power. So my final answer is 16g to the 4th, h to the 12th. So I'm interested in this box right here. Remember, to get credit for your notes, you need to do the lesson summary and the practice problem. I'm going to try to keep them pretty simple. This one I'm really interested in. Don't write out the question, but tell me, what do you think is easier? How do you understand it best? Writing out the long way or using the shortcuts? Are you at the point where the shortcuts work? Or do you need to see it? Because a lot of times people need to see it. Keep in mind, we're going to add on to this with lesson 7 too. So what is easier, writing out the long way or using the shortcut? Tell me what works best for you, and of course, why. Don't just say writing out. Why? Do you need to see it? The shortcuts don't make sense to you. The shortcuts are easier because you understand what you're doing. What's easier for you? And practice problem, simplify 3x squared to the 3rd power. You can double check with the shortcut. Please write it out the long way though. I want to make sure I see that everybody understands what that long way is. That's all I got for you. Have a great day. We'll see you guys later.